So, hi everyone. My name is Liat, and Marian is with me. We both work in Nvidia, and we will talk about smart switch on this session. The idea eventually is that to create a single platform which has its one pizza box, that in that we will have a switch ASIC and we will have multiple embedded DPUs. The switch itself will be with a regular uplink ports like we do have on T0, T1 switches, but with the extended and capabilities that the DPUs provides into the network. What we will do in the session is that we'll go over some use cases and the benefits that we see with the smart switch, and then we will talk about how we can integrate smart switch into the SONiC architecture. There are a few options. We will review all of them, and then we can go on and ask a few more questions. So for the use case, Marian?
Yeah, so about the use cases, so the initial thought behind the smart switch is to try and integrate a switch usually in T1 layer, a little bit higher from top of rack, with the smart appliance. So there is the main function of the network that serves connecting all of the hosts in the rack, plus some additional stuff that we would need from time to time, like stateful network functions, different kinds of security, et cetera, et cetera. So what we want to bring first is the same functionality that appliance can provide you when you plug it into your network. So first one is the SLB. Assuming that we can now easily do connection tracking at line rate in the DPUs, server load balancing will be one of the first tasks to tackle. And it will provide us with the dip pool updates to our server pools without breaking any connections. Since we have the full flow table, we don't need to worry about it. Also, on the same subject of connection tracking, we can do stateful ACLs, firewalling, so we can define policies for DPUs that allow VMs to go to open connections only in one way and monitor all that. Then we can enhance functionality of the switch itself, provide capabilities for the internet scale router at a lower cost, where switch ASIC can serve as a cache for the top talkers, like providing a smaller routing table for most of the bandwidth, and then extended routing scale with DPU. Then we can enhance other policies, like enhance ACL scale. Same thing, we provide the basic scale for the top talkers inside the switching ASIC, and then extend it in a smart way with the DPUs. So you can imagine that these tables are kind of fluid. They do not stay the same. They're not provisioned by some higher entity like controller. So the smart switch can decide which are the top talkers, move them to the switch, which are less frequently hit, move them to the DPU, and solve the scaling problem that way. And also do the CPS and PPS limiting per VM, since we are working in the context of the overlay in the DPU. And also security. So DPUs usually have all of the hardware capabilities for doing different kinds of encryption, gateways, etc. So we can offload that portion to the DPU. And usually, if we're talking about gateway, it's again a smaller portion of the bandwidth compared to the whole switch itself. And also resiliency, like we can, if we're talking about stateful workloads, we will need to provide the resiliency, and we can achieve that with the combination of switch ASIC and a DPU as well, and provide full active-active scenarios. So these were the functionality of the appliance that we want to bring into the switch, plus we are getting some additional benefits on top. First one is cost. So we don't need to host DPUs in a dedicated PCI racks, etc., in a dedicated host. We reduce cabling because DPUs are now sitting on the same board as the switching ASIC. We can provide a uniform management in the long run, meaning that we have single controller view, shared management IP, shared underlay IP for packet processing, single sonic image, single software update procedure. You don't need to worry about software upgrades for each of the ASICs separately. Scalability and performance as well. Even compared to the appliance, because we can provide smart load sharing now that we see this as a whole system, extended scale, that's what we pretty much were talking about, and also reduced latency because they sit closely one to another. And programmability, we can do more optimal and shared pipelines with switch and DPU as opposed to two separate devices. We can dynamically load changes without controller involvement, like do ISSU and other stuff without any traffic disruption, anything like that. And also provide high-level languages support to actually program those two as a single pipeline. So yeah, so this is additional benefits. And moving to software, Liat will continue.
Thanks. So what we will, just a moment.
Yeah, you skipped one step.
This is, okay. So before we go over them, we have like, we are using the same sonic architecture that we have today. And what we want to show is that there are a few options where you cut in the middle, whether you are doing that like a different NOSes running on a different ASICs, or you are doing some a layer that knows how to distribute everything, and everyone has its pros and cons. We will go over all of them. We are not saying what is the right way for now. We are just saying what are the options, and as long as the discussion and the technical parts will get into more like concrete, then each one of them will be analyzed, and then the community will decide where to go. So the first one is kind of saying that we have a controller, and the controller has most of the knowledge what's to do and how to configure the network. The fact that we have a single box allows us to do most of the things that Marian has just pointed. But from sonic perspective, each of the ASIC has its own, let's call it life. It has its own database, and moving forward, we have like duplicating the ORC agent per ASIC. And it can be that each ASIC runs on a different, let's call it different CPU. In the box, we will have a CPU that will control probably the switch ASIC. But most of the DPUs has their own CPU, most of them has the ARM CPU, and that can run on top of the ARM CPU. Thanks. So the pros here is that the controller has the full visibility of that, and still one of the main problems that we are duplicating the logic, but everything is on top of the controller. The next one is kind of unified in the ORC agent, meaning that from the controller point of view, he just work on top of a single application DB. He just go over through the ORC agent, which has an interface to each of the ASICs syncd, which is everyone has its own SI, own SDK, own life. One, like from the DPU part, since we have the CPU, everything can run, the syncd can run on top of the DPU itself. But the logic itself is like a generic layer, which the ORC agent is doing all the smart things. Like whenever there is a need to go through the switch ASIC, it will configure the switch ASIC, and whenever there is a need, it will configure the DPU itself. And all the logic is on the ORC agent. I will not go on the pros and cons of each one of them. You can see it here. But the idea here is that most of the logic is open, meaning that we are having a single ORC agent which is doing the extra decisions taken. And then each, let's say, each vendor has its own implementation of per ASIC, and then we can have a very concrete, like a full picture that is open for all. The next one, which is much more flexible in that term, means that you are reducing, let's say, responsibility from the controller, and we're moving that to a different layer in Sonic, which is the syncd. But the main problem here is that if you have a multiple, let's say, ASIC vendors, like if you have a DPU from one company and another one from an ASIC from another company, then the syncd needs somehow to know how to do all the balancing between all of them. But still, from the up side to the lower side, then the responsibility is less on the upper side, more like on the lower side. Basically, what I believe that will happen is that we will have to see what is the controller responsibility in that area and decide what is the best way where to cut the parts and put it on whether it's the community parts and whether it's the vendor part, and see what is the pros and cons of each one of them. I think that that's the idea. Questions?
So you said that DPU has its own CPU. So on all these cases, on which CPU you would have SAI running for DPU?
We can see it here.
I mean, here it's clear.
Here it's clear that the entire, let's call it the entire Sonic can run on top of the DPU CPU.
Okay.
Meaning that you have all the NOS running on that, and so the Mestly is the application, SWSS, and syncd running on the host CPU, on the host DPU. Okay? So
it will be 3 different instances of, in this case,
yeah.
Of the Redis. Right. One runs on the NPU itself on the switch, and each one on the, and the connection is done through the management, or?
Correct, through the controller. The controller is going to manage which item will get the information. So you will need
to have the management connection to each DPU as well. Correct. Even if it's the same appliance, you will have, in this case, 3 management links.
Correct. Okay. Each one of them is management independently, and the one that manages them all is the controller.
Okay, and what about PHY case? If you will need to put a PHY here, how you will stick it? How you envision to put it?
What do you mean PHY?
Like a PHY chip. You can also have SAI for the PHY.
Like the cables themselves?
Yes, definitely.
Okay.
So should it be like, should we treat this as the yet another SAI object here, or it should be like hidden between all of?
You mean an external PHY?
Yes.
That's the idea?
Yes.
Okay. So right now the external PHY is managed in the Sonic itself, right? So here, because it's a pizza box, right? Each DPU has the connectivity inside the box. You don't get it out. So I think it will be it's not an appliance, okay? It is one pizza box that has all the DPUs connected to the CPU, connected to the ASIC, okay? There is like the ports, as Marian mentioned, you are removing the dependency on the cables between the DPUs and the switch, and then you can have a very, let's say, simple driver that's doing the work. You don't need to manage that in a way. But it means that every port, right, has its own external PHY, and it needs to run on top of that.
Thanks.
Thanks. Actually, we have time at the end for 3 talks to have questions.
Okay.
Yeah. So how about that? We go to the second and third, and then we have time for questions at the end. Yeah.
Sure.
The next one is Rashma.